Hello, this is Jihoon from We Learn to Share. Today, we'll be going over the 2024 AP Calculus BC FRQ, Part 1, for this video. Okay, so number 1, so we have the temperature of a coffee in minutes modeled by in degrees Celsius, okay? A, approximate this using the average rate of change. So, what is average rate of change? Average rate of change is the slope of the secant line. And in this case, the slope of the secant line is C of 7 minus C of 3 over 7 minus 3. And that is equal to 69 minus 85 over 4, which is equal to negative 4. So we have to include units of measure. And in this case, it's Celsius over minutes or per minute, because as you can see here, C of t is measured in t minutes and it's measured in Celsius. So in our response, we would write just something like C prime of 5 is basically negative 4 Celsius per minute. Yep, that would give you a point. Next, use a left Riemann sum to approximate this, but we also have to interpret meaning of 1 over 12 of something. So when we're giving a Riemann sum question, it's better for us to actually draw a graph. So I'll just come over here and make a graph. So from 0 to 3 to 3, 3, 7, 12, 100, 85, 69, 55. And we'll get the points here. Because this is a left Riemann sum, we have to get it from the left. So we'll be doing this, this, and this. These 3 tables. And now we can go back to our equations here, and we can say that integrating from 0 to 12 of C of t is approximately equal to, the rectangles say that it's going to be 3 times 100 plus 4 times 85 plus 5 times 69. And that is going to be equal to 985. Okay, next part is dividing this by 12. 1 over 12 of 0 to 12 C of t. So you need to remember that when you see something in this form, 1 over b minus a, integrating from a to b of some function, this is the average value. Okay, this is the equation for the average value. So what we can say about our function here is that this is the average temperature for the coffee from t equals 0 to t equals 12, and that would give you a point. Next question, so we have a C prime of t given to us, and what we have to do is find the value of c of 20. So we would say that c of 20 is equal to something. So what should the something be? Well, we can't just do integrate from 0 to 20. Like, we cannot do this, because first of all, c prime of t is defined only for 12 to 20, and that means that from 0 to 12 we have to use another method, and we can get c of 12 from the table, and it's 55, and what we add is from 12 to 20, the c prime of t, and this is going to be equal to 55 minus about 14, and that is equal to 41, around 41. You can use your calculator, so you shouldn't try to solve it with your hand. Okay, next, determine whether the temperature is changing at a decreasing rate or increasing rate. Well, we can just plug in t from 12 to 20 for c prime prime of t, right? No, you actually don't need to. So try to see the equation again. So this is equal to something e to the 0.0 t 1 minus over this. So what we care is not the value but just the signs, okay? So that's why I didn't write the constant at the front. Well, we know that from t 12 to t equals 20, as you can see from the question written here, this part is going to be positive, right? This part will also be positive, and this part will also be positive. So it is always bigger than 0. So what does it mean when c prime prime of t is bigger than 0? If c prime prime of t is bigger than 0, c prime of t is changing at an increasing rate, right? Because c prime prime of t is the rate of change of c prime of t. So if it's positive, c prime of t is changing at an increasing rate. Okay, so not that hard, right? It wasn't. Okay, so next question. Number 2. A particle is moving at this. So the most important part here is probably this and this. All right. A. Find the speed of the particle. If you saw the question, it's actually in a vector form here, as you can see here. That's actually pretty important because in a vector form, the speed of a particle is not just velocity or something. It's actually, absolute value of velocity. It's root of x prime of t squared plus y prime of t squared. And in this case, we should plug this two values in, but it's kind of hard to, and it's kind of tedious, so you can just leave it to your calculator to do it. And so s of t is, if you use your calculator, it's going to be equal to around 12.3. 12.3. Okay, B. Find the total distance. So when it says distance, it's not talking about displacement where you just take the integral of a velocity function. It's the integral of the speed function, and that is the total distance. So in this case, it would just be from 0 to 12 integrate s of t. And again, use your calculator where you plug in this equation in, and you, oh sorry, it's not 12, it's 2, and you should get around 15.9. Okay, next, find the y coordinate of the position of the particle at t equals 0. Show the setup. So it's talking about the y coordinate. So we can say y of 0 is something. This is actually similar to the previous question, but in this case we're doing something different. So let's just try taking an integral from 0 to 20 of, I don't know, a y of t. That is equal to y prime of t. That is equal to y of 20 minus y of 0. I'm sorry, y of 2. Using this, you can make it so that y of 0 is equal to y of 2, y of 2, not 20, y of 2 minus integral is equal to y of 0. So we can use this formula for this question. As we see from the prompt, it says at time equals 2, the y value is 6, as you can see here. So that means that y of 2 is 6. So we can write 6, and we can just do that. You can use your calculator, and you would expect something like negative 1.17. Negative 1.17. Okay. Next. For this, the particle remains in the first quadrant. Find all times when the particle is moving towards the x-axis. So when you see something like this question, it's better to draw. So try drawing a graph or visualize it. This is saying that the particle is over here when it's positive and positive. And when is it moving towards the x-axis, which is this? Well, that's when y prime of t is less than 0, because it's gonna move down, right? So what we just have to do is find all instances when y prime of t is less than 0. So you can probably use your graphing calculator or whatever, and you will find that y prime of t is less than 0 when t is between 8 and 5.221. 5.221. Because our particle is on the first quadrant. Okay, or something like that. Okay, so I hope that this video maybe gave you more insight into how to solve FRQ problems, and I hope you keep practicing until the AP test. Good luck and thank you.